Alright guys, for a two tails, then our p-value is found by first making note of the z-scores that you found in the test statistic, and then you look up the table using the left z-score to find one area of that region, and then you double that area, and that's how you find the p-value, which is a little bit different from the first two. Okay, so make sure you make a note of that. Now it is time for us to kind of make our conclusion, because we did all this work, and then we're going to go ahead and make our conclusion now regarding our claim. So we make a conclusion based on comparing the p-value to alpha. Okay, and remember, p-value is this area, and then alpha is kind of like your significant level, which would have been given to you in the problem. And so you compare those two, and then you kind of make your conclusion based on those comparisons. Okay, so if you compare and your p-value happens to be less than alpha, then you conclude that you would reject the null. And by rejecting the null, you're saying that there is enough evidence to conclude that our alternative hypothesis is true, because we're rejecting the null, right? We're rejecting the claim. All right, we're rejecting the null hypothesis. All right. However, if your p-value is greater than alpha, then you're going to conclude that you do not reject the null. Another way to say do not reject the null is to say fail to reject the null. And by failing to reject the null, we're saying that there is not enough evidence to conclude that the alternative hypothesis is true. Okay. Now, there will be times when we draw a conclusion. We hope our conclusion will be correct, but sometimes it will be wrong. There are two types of mistake that we can make when this happens. We say that we would make a type 1 error if we reject the claim, or we reject the null, to be more specific. Okay, and the null, it's kind of like your HO when the null is true. Okay, so if we reject this, we reject the null, and the null happens to be true, then we have made a type 1 error. Okay. On the other hand, if we don't reject the null when the alternative, which is your H sub A, is true, then we have made a type 2 error. Alright, so make sure you look over type 1 error and type 2 error. Take your time, read it a couple times, let it sink in, so that you know which is which. I made this flow chart so that you can so that it makes it easier for you to go through steps by steps to set up a claim, and then eventually to state your conclusion. So a typical problem will involve a claim is being made once, and also a significant level will be given to you. Once you have read your claim and identified the significant level, the next step is to move on to setting up your hypothesis testing. Hypothesis testing looks kind of like this. This is called hypothesis testing. This is called setting up hypothesis testing. Once you've set up your hypothesis testing, then the next step is to move to find the test statistic. The test statistic are those are these values. These are the test statistic. Okay. Once you have found the test statistic, which is going to be a z-score, then from there, then you would move on to either the left tail. If you see a less than, then you move on to the left tail. If you see a doesn't equal to, then you move on to a two tail. And last, if you see a greater than, then you move on to a right tail. Okay. So remember that a two tail looks kind of like a left tail looks kind of like this. This would be your test statistic z, and then you would find this area, which we call it the p-value. For a two tail, then you would take your test statistic z and you would write them here respectively. You shade these two regions. You look up to find the area for that region, and then you double it to find the area for both regions, which is what we call the p-value. For a right tail, you would only shade the right portion of the normal curve, and you look up to find that area, and that's your p-value. So either way, you find the p-value. So all this graph converge over here to the p-value. You find that p-value. Once you find the p-value, then you move on to the last step, which is the compare. You want to compare your p-value versus alpha. Okay, and then once you compare that, then you can make your conclusion depending on how it turns out. So let me walk you through a couple of examples on how we would be able to set up a claim and then eventually make a conclusion. Okay, so in today's claim, we're just going to talk about the percent of the population. We call that a proportion. That stands for percent. And the test statistic that we use for proportion is z equals to p hat minus p divided by the square root of p times q over n. That's our test statistic. That's the most important formula. Okay, so let me show you how to set up a claim and then test a claim and then write a conclusion. So the first thing we do is we identify the claim and then identify the significant level. So the claim is that more than 25% of the high school students have jobs. So here's our claim. The percent of students who have job is more than 25%. Okay. And then the opposite of our claim, would be the opposite of more than 25, guys, is less than or equal to 25. That's the opposite of that. Okay. And remember that we got a significant level of 0.05. So I have a claim is made, significant level is given, identify that. Now I move on to the next step, which is setting up my hypothesis testing. So my hypothesis, my null hypothesis, and my alternative hypothesis. Now, the easiest way to identify the null hypothesis and the alternative hypothesis is by looking at these two lines that we wrote down earlier and ask yourself, which one contains an equal to symbol? So this guy right here contains an equal to symbol. Thus, your null hypothesis would be p equal to 0.25. Your null hypothesis is this guy, okay? Which means that your alternative hypothesis has to be the other guy. So p is greater than 0.25. Right? That's setting up your your hypothesis test. Right? And make sure you pay attention to how I came up with these two alternative and the null. Okay. Once again, the null hypothesis is by analyzing this above previous line and ask yourself which one contains an equal symbol. Since this one contains an equal symbol, that's your null, and if that's your null, then the other one is your alternative. We set that up. Now we find the test statistic. So put this in a box. my test statistic. That would be my z symbol, my value, but I need to know p hat before I can find that. So in order to find p hat, we need to know the sample size, which is 510. We need to know the number of students that have jobs, which is 203. So p hat comes out to be x over n. And if we use a calculator to do the math, then we are going to get 0.3980. So this is 0.3980. Okay, so go over here. And then we calculate our z value by taking 0.3980. That's your p hat. Minus p. What's p? P is 0.25. Divided by the square root of what? A p times q. A p times q divided by n. N is 510. Okay? So you punch that into your calculator and you're going to get a number. It should come out to be 7.72. Alright? So here's where we're at right now, guys. We have found our test statistic z. And then the next thing we do is we sketch a left tail, a two tail, or a right tail, depending on what our alternative symbol is. Since we're dealing with a greater than symbol, we're looking at a right tail. So you sketch your right tail. You label, this is the 0 in the middle, and all the way to the right is 7.72. You're really shading this area. Now, if you look up 7.72, you're going to get 0.9999. And 0.999 refers to like the area to the left. Okay? But you're looking for this area, and that's your p-value. So your p-value is equal to 1 minus 0.9999. Because like I said, if you look up 7.72, in the z-score table, you're going to get 0.9999, but you're looking for the p-value, which is the area to the right, so you have to subtract that from 1, ending up at 0.0001. Okay? So that's your p-value, and then you found the p-value. Now it is time for us to make a conclusion. So we compare between p-value and alpha. Alright, and then we're able to write a conclusion there. So we know that p-value is less than alpha. Okay, so here is our conclusion. If p-value is less than alpha, okay, we reject the null. There's enough evidence to conclude that the alternative hypothesis is true. So we reject p equals to 0.25. There is enough evidence to conclude that the percent of high school students with a job is more than 25%. Okay, so if you're rejecting this, you're accepting that. You're saying that there's enough evidence to accept that. Okay, awesome. Let's do another one. Suppose a nationwide survey showed that 70% of all adults population favored the concept of euthanasia for terminally ill patients. Test whether this is true if 666 of the sample of 900 are found to support the concept. Use 5% significant level. So the first thing we do is we identify the claim and the significant level. Okay, so the claim is that it says that 70% of all adults favor the concept. So they claim that 70% favor the concept. The opposite of 70% is not equal to 70%. That's the opposite of 70%. Okay. And remember that our significant level alpha is 0.05. Now we've done that already. We identify the significant level. It is time to move to hypothesis testing. So hypothesis is your null hypothesis and then your alternative hypothesis. Ask yourself which one contains an equal sign. The first one does. That's your null hypothesis. That's your null hypothesis, and that automatically makes the other one your alternative hypothesis. Okay. You move on to find the test statistic. Alright. Identify your sample size, which is 900, the number of patients who favor that concept. That allows you to find your p-hat. And if you take 666 divided by 900, then you will get 0.74. Okay, once you have that, then you can calculate your z-value by taking 0.74 minus p divided by the square root of 0.74 times 0.7 divided by 900, which is the sample size. Okay. Now remember, I got this from there. I'm plugging into this formula. That's how I find those values. So using a calculator to punch that into a calculator, you will get 2.62. Alright, so here's where we're at right now. We found the test statistic, and it's time for us to move on to one of these three. We know that's a two-tail because of the doesn't equal to symbol. So you draw yourself a normal curve, label negative 2.62, label 2.62, shade in the two tails, and then we look up 2.62 to find that area. By looking up 2.62, you're gonna get an area of 0.004. But remember that the p-value is twice that area. So you go twice that area, which gives you 0.0088. Okay, so we found the p-value. And the next thing we do is we compare that to make a conclusion. So we're going to compare 0.0088 to 0.05. And by comparison, p-value is less than that. So if p-value is less than, then we reject the null. Okay? So we reject this. If we reject this, that means we're supporting that. There's enough evidence to support this. There is enough evidence to conclude that the number of patients who favors euthanasia is not 70%, implying it is more than 70%. Awesome. I will see you guys in class next time.